Hello serpents, and today we'll be talking about HTTP header. So this is actually a requested video from one of my subscribers, and here I am. In this video we will look at some vulnerabilities or scenarios where you can use some uncommon headers to exploit or either bypass certain features in a web application. So it's a bit of random, but we will look at all the different cases where you can use such headers to test while you're exploring a web application. So first one we have here is the rate limit bypass. So what is rate limiting? Rate limiting is a security control that limits how many requests a user or IP can make in a certain time. So it helps to prevent brute force login, credential stuffing, API abuse, or DDoS. But it can also be bypassed with headers, as many web applications sit behind proxies like Nginx, Cloudflare, or AWS ELP. The server doesn't see the original user's IP, it sees the proxy IP. So to solve this, proxies add headers like x_for or xrealIP in the request, and apps read this header to know the true origin IP. Now, you can also add this header in the request and add a particular IP address to it to bypass some certain restrictions. So some applications trust these headers blindly without checking if they actually came from a trusted proxy. In that case, an attacker can inject fake headers. Let me show you an example. You can see the heading says rate limit bypass via x_for header manipulation on registration page. So basically, by adding the x_for header in the registration page, so basically in cases like this, there is some kind of restriction after some particular number of attempts. Let's say you tried putting the password 30 times and then the app blocked you for your attempts. So your IP is now blocked, but you can still try to attempt adding or trying more passwords by putting the x_for header. So it can lead to bypass. In this one, there is one more header that is client IP. So as you can see, it says provided they manage to directly connect to Puma, an attacker can spoof their IP address by setting the x_for or client IP HTTP header and use that to bypass most rate limiting. So this is how you can exploit those headers to bypass rate limiting. When you're hunting and you see some kind of rate limiting, you can try this out. Let's move on to the next one. The next one we have is Auth Bypass via x_for or xrealIP headers like that. So many web applications or APIs restrict access based on client IP address. Example, only allow requests from internal networks or admin IPs. So the server or app often gets the client IP from the incoming connection, but sometimes it relies on headers like x_for or xrealIP to determine the client real IP, especially when behind proxies or load balancers. If the application trusts these headers without proper validation, an attacker can spoof these headers with a whitelisted IP address like the localhost IP or in some other internal IP. So as a result, the attacker bypass IP restrictions and gain unauthorized access. So as you can see here, it says the directory normally returns a 4.3 forbidden HTTP status code when accessed normally, but Acunetics managed to bypass this restriction by spoofing the x_for HTTP header and set various internal IP addresses. So basically, it trusted the value in the x_for and assumed the request is coming from an internal IP address that led to bypass. And the remediation here would be to not use x_for HTTP header for access control list checks because it can be spoofed by attackers. The third one is host header injection. So we are going to talk about this particularly in password reset, as this happens when a web application trusts the host header in the request to generate URLs like ones sent in the password reset emails without validating it. So when you basically intercept the password reset link and you change the value of the host and you send the request, in the email or the inbox, you will see that the password reset link has the customized domain value like evil.com or attacker.com instead of the original domain. Sometimes this doesn't work either. In that case, you can try adding X forwarded host. Let's have a look at this example. So this is a lab I picked up from the post figure, and here we have the password reset functionality. So once you see the password reset, get this in your burp, capture the request, and try manipulating the host value. But if the host value is not working, for example, you don't see the host value changed in the reset link, you can try another thing. That is, you can capture the request and add a header X forwarded host. Now in the X forwarded host, you have to provide your own domain value, your collaborator, your interact SH, or in this case, the exploit server. So we're going to copy the exploit server URL and paste it in the X forwarded host value. Capture the request in the response, and in the response, we can see the href attribute contains our URL. Means it is very likely working. So let's go back to the exploit server, and in the access log, if the victim clicked on it, we should be able to see their access token, and this can lead to account takeover. So you can see how severe it can get. The fourth one is web cache poisoning. So cache poisoning is a type of attack where an attacker stores malicious or fake content in the web cache like CDN or reverse proxy. So the future users receive the poisoned content instead of the legitimate one. I actually have made a dedicated video on web cache poisoning, so you can check that out from the I button. So back to this one. Web caches like CDNs or reverse proxies cache response based on URLs and sometimes certain HTTP headers. It could also be parameters or some particular value in the HTTP request. So some caches use headers like host, X forwarded host, or X original URL to vary the cache key. But if the server reflects or uses these headers and responses without proper validation, you can poison the cache. Let's have a look at this report. This researcher first captured the GET request to this particular endpoint. This was reported to Shopify. So as you can see, there is a header added over here, X forwarded host, that contains the burp collaborator URL. Now in the response, the burp collaborator URL is being reflected in the href attribute, as you can see. So now by sending this request like multiple times to an intruder, you can poison the cache. Let's have a look at another report. This one is denial of service via cache poisoning. So an attacker can persistently block access to any or all redirects on it's on HackerOne itself by using cache poisoning with X forwarded port or X forwarded host headers. Now, when you're not sure which header to use, you can always use param-miner to decide which header, or you can also try manually, but you can also use param-miner, of course, or you can use some list of headers. You can get that list from GitHub and you can try that out. So to replicate it, first send a request to this particular URL with the value X forwarded port 123, and then try to load this page in your browser. The attack can also be done using the X forwarded host. So here is the image as well, and you can see it says this page can't be reached. This is happening because the port here is 123 and it's not a correct one, and because this is an invalid port or an invalid host, victims will see that particular page. But as an attacker, they can send a lot of requests and run this in a loop using some scripts, and it will be permanent DOS. So this is a pretty good one as well. The last one is HTTP method override. Now, this itself isn't a particular vulnerability, but there are some particular headers that you can use, like X HTTP method override or X method override or X override method. These are some few headers that you can use to exploit cache poisoning as well. So we're going to look at this report. So here's the example, and it is cache poisoning, but we are using a different header here. which is X HTTP method override. So by providing the value head in this particular header, the server honors this more and it generates a 200 OK response with an empty body which gets cached, and as a result the resource becomes unavailable for all users. That leads to denial of service. So basically sending a lot of requests with this particular header and value to this URL, it can poison the cache. Now I want to point that out that not all the programs accept DOS, so it actually depends on the application. They might accept it, but they might not give a bounty for it, for example, in this case. But in some cases, they definitely do. For example, in the previous cache poisoning we saw, in which the guy was awarded with $1,000 bounty. So it depends on the program and how much impactful it is. But I just want to show you some examples so you can try this out, either in bug hunting or pen testing. Okay guys, that's it for this video. I hope you learned something from this video or revised something that you may have forgotten. But again, I hope you enjoyed it. So thanks for watching and I'll see you in the next one.